Now that we know what CRISPR stands for, we should see where it comes from. CRISPR sequences are found on the bacterial genome, guiding Cas9 endonuclease to cut the coordinating sequences on viral genomes, protecting the bacteria from infection. To perform CRISPR genome editing, we use a Cas9 protein, most often from S. pyogenes, but sometimes from another bacterial species. To program the Cas9 protein to cut where we would like it to cut on the genome, we use a guide RNA, or gRNA for short. This gRNA lines up with the part of the genome that we would like to cut. The Cas9 makes a double-stranded cut, and then the cell or the body repairs it, but it's an error-prone repair, and it causes a possible mutation, which can cause what's called a knockout. And by similar mechanism, we can do a knock-in. Now that we have our Cas9 and guide RNA, we need to get them into cells. Instead of transporting a protein, we use the DNA sequence for Cas9 on a promoter, often on a small circular piece of DNA called a plasmid. This is an example of a basic CRISPR plasmid map. This plasmid is then carried by either a virus, such as AAV or lentivirus, or a lipid nanoparticle into the cell, depending on its application. While there are too many to list here, these are two very different uses for CRISPR genome editing. If you're interested in learning more of the applications for CRISPR, please check out my description box for links to more articles and papers on CRISPR. Thank you.